Let us discuss now the QoS flow type and associated QoS flow parameters. So as we had discussed that there can be a GBR QoS flow, that is guaranteed bitrate QoS flow. There may be a non-guaranteed bitrate QoS flow and GBR flow. So both type of GBRs and non-GBRs flow will have certain QoS flow parameters, and these parameters are: for non-GBR it is 5QI, ARP and RQA. So 5QI is 5G QoS identifier, and ARP is allocation and retention priority, and RQA is a reflective QoS attribute. In case of GBR flow, guaranteed bitrate flow, in addition to 5QI, ARP and RQA, it will have GFBR, MFBR, notification control, and maximum packet loss rate. So GFBR is guaranteed flow bitrate and MFBR is maximum flow bitrate. And now this 5QI, 5G QoS identifier will have these parameters. That is, first one is resource type, which is whether it is a guaranteed bitrate GBR or non-guaranteed bitrate non-GBR, or it is a delay critical GBR. And then it will have a default priority level, and you have PDB, which is packet delay budget. So how much maximum delay can be accepted for a particular 5QI value is given by PDB. Then you have PER. So PER is packet error rate. So how much error can be allowed into for a particular QoS flow. And then you have default maximum data burst volume, which is used for critical GBR, and then default averaging window. So default averaging window is a time in which all these parameters are averaged out. So these all are average parameters within the averaging window. So now let us discuss these parameters in bit detail. So let's first talk about ARP, allocation and retention priority. So let us take an example that in a particular QoS flow or particular PDU sessions, there are more than one QoS flow running, and because of the crunch or the constraint onto the, say, radio bearer or any other resources, both the QoS flow cannot be supported. So which one to retain and which one to drop is actually decided by ARP, allocation and retention priority. So based on ARP value, a particular QoS flow can be dropped and the other QoS flow having a higher ARP value will be retained. Now let us talk about RQA, reflective QoS attribute. So what happens is that in case of a non-GBR flow and also in GBR flow, reflective QoS is the QoS flow mapping by the UE based on the QoS flow which is coming onto the downlink direction up to the UE. So UE drives those QoS flow parameters from the downlink and applies onto the uplink. So it doesn't require kind of QoS rule from SMF which comes through AMF 1N1 interface. So it applies if it supports. So it is an optional whether a particular UE or particular network supports reflective QoS. In case it supports, it can apply reflective QoS. And then let me discuss about notification control. So notification control is nothing but suppose there are many quality of service flow already established within a PDU session, and in case the G node B is not able to maintain a particular QoS flow, then it will notify that to the core network that it is not able to maintain the particular quality of service. And then suppose after some time network become normal and it is able to support the QoS flow assigned, so again it will send a notification to the core that yes, it has again started supporting the QoS flow. So this information when goes to the core may be used for charging, etc. So this is what a notification control is. And let us talk about some of the 5QI parameters like default priority level. So when the rules are say sent to UE to apply a particular QoS flow, map a particular QoS flow onto the packets which is going towards uplink direction. So which rule is to apply first and which rule has to be applied next is decided by the default priority level of that particular rule. So this is how the rules are applied by the UE.